next one together. This problem is very similar to our last one, but it has a little gotcha hidden in the units that we need to be careful about. So we're still diluting a solution, but we're starting with molar and trying to reach millimolar. So the problem says, calculate the volume in milliliters of a 1.5 molar NaOH stock solution required to make 275 milliliters of 50 millimolar NaOH. And then it says round to 1 decimal place. Alright, so step 1 is let's go ahead and identify our variables. So we know M1, that's going to be our stock molarity. And that is 1.5. V1, which is our stock solution or stock volume. And so this is what we are looking for. M2 is going to be our final molarity. And that is going to be 50.0 milli, let's delete that, millimolar. And V2, which is going to be our final volume, is 275 milliliters. So step 2, we're going to have to do some unit conversion here. And so before we can use our dilution formula, our units for concentration must match. We have molar and millimolar, so we need to convert 50 millimolar into molar. So since milli means 1,000, there are 1,000 millimolar in 1 molar. So let's put this in, so millimolar over 1,000. And we're going to divide that through, and we get 0.05 molar. So now we come to step 3. We're going to apply our formula. So we've got M1V1 equals M2V2. And we want to go ahead and isolate V1. And so to do that, we're going to divide both sides by M1. So let's do that. V1 is equal to M2 times V2 divided by M1. So now let's come to step 4, and we're just going to plug and play. So V1 is equal to 0.05 molar times 275 milliliters divided by 1.5 molars. So if we multiply the top, we get 0.05 times 275, and that's going to come out to 13.75 divided by 1.5. And that's going to give us, it's going to be somewhere around 9.1666 kind of continuous. So the problem asks us, if we come back to the problem, to round to 1 decimal place. So the second decimal place is a 6, so we're going to round up, and our final answer is going to be 9.2 milliliters. close attention to that millimolar versus molar distinction, we're able to avoid this huge error. And so in that lab, you would measure out 9.2 milliliters of your concentrated NaOH and add it to a flask. All right, let's move on to the next one.